All right, so we can get started here on the tutorial. So the plan is we're going to do the first half of the tutorial now. We're to start with what we call static scenarios. Yeah, oh, go ahead. Yeah. So scenarios where we're just describing things at one moment in time, which would be enough, for example, if you want to generate like synthetic images to train some classifier or something like that, maybe. Then after the break, we'll talk about Scenic's features for writing dynamic scenarios. So things changing over time, objects moving around, etc. And then I may talk very briefly at the end about some additional, more advanced Scenic features, just to give you a heads up that they exist, so that if you want to play around with them this afternoon, we can do that. I may end up doing that after lunch because in both the halves of the tutorial now, we'll have Colab notebooks for you to work in. So I will just talk briefly for 15 minutes, maybe at the beginning here, and then let you try out this Colab notebook yourself. But then after lunch, we'll have time for you to play around with Scenic, try more advanced things, maybe more specific based on your interests on your own computers. So right before lunch, we've set aside some time for those of us on the Scenic team to help you get it installed on your computer so that after lunch you're ready to go with doing some experiments locally. Okay. So first, a very brief history of Scenic, because if you read our papers, you'll see various different versions of the language, and the syntax has changed somewhat. So I just want to start to clarify that a little bit. We're going to be using Scenic 3, which is the latest version. In our first paper on Scenic 1 only was able to do static scenarios and only really 2D scenarios. And the only simulators we had interfaces to at that time were GTA 5 and Weebot. Then in Scenic 2, we added syntax for dynamic scenarios, but it was still only in 2D. This is what's in the journal paper. And we added a cross simulator driving library, which lets you write scenarios, driving scenarios that then work out of the box in multiple driving simulators, in particular Carla and LGSVL. And then finally, the most recent version, which is what we're going to be working with, adds full support for 3D scenarios and it models the shapes of objects, so Scenic can understand when things collide or do not, or when one thing blocks the view of another thing, etc. And also allows you to express logic requirements in temporal logic. So that's the version we'll be working with. If you go back to read some of our older papers, you might notice the syntax is a little bit different. Okay, so writing static scenarios. So I'm going to take this example that Sanjit put up before of the badly parked car. Here are 4 different samples from a single oh, actually, no, not yet. Sorry, this isn't animated. This is just a single image. I'll show more later. So suppose we want to model a scenario like this. You've got a car which is parked on the side of the road, but it's at this kind of funny angle. So schematically, that could look like on the left here. On the left, you've got the ego car, and the blue dotted cone is showing the view cone, the camera of the ego car. And then in the bottom right, we have the other car, which is near the curb, but a little bit too far away, and that kind of a funny angle. So that's what we want to try to model. The first thing we're going to do is use Scenic's model statement to import the driving domain library that comes with Scenic. This is essentially a Scenic library that defines what is a car, what is a road, what is a lane, etc. All of those concepts are not built into Scenic because, as Sanjit mentioned, Scenic is designed to be usable in many different domains besides driving. So it doesn't have any of those concepts built into it. It only knows about geometry in general. So we're first essentially importing this model. And then using that, we can create a car. So we're setting the ego object, which is just a special object in the scene that's used as the reference point for various of Scenic's operators. And we're setting it to be a new instance of the car class, where this car class came from that model we imported. And notice here that we are not saying anything about this car, like where it is, what color it is, etc. So Scenic is going to use the default values for all of those properties, position, orientation, etc., that are defined in the car class. So in particular, the car class defines the position of a car by default to be uniformly at random over the road surface. So it has probability 0 of being on a sidewalk or inside a building, for example, but it can be anywhere on the road. And that's a reasonable default, but you can override that if you want, as we'll see later. Okay, so that creates the ego car. And now we're going to position the badly parked car at a few steps. First, we're going to pick a random spot on the curb. And we're going to do that by taking the curb region. Whoops. So if you look, I've zoomed in the picture on the right here. The red line on the right is the curb of the road. We're going to take the part of that region which is actually visible, so that's now highlighted in black, and pick a random point in that region. And how that's done in the Scenic code is first we're starting with this region curb. So region is a primitive data type in Scenic representing some region in space. And the driving model, which we've imported, defines the curb region by loading in a map, a map of the road network in a standard format called OpenDrive. Here, I actually haven't shown which OpenDrive map we're using, but you can specify that. This scenario would work with any such map. So we're taking that curb region, and now we're applying a built-in function in Scenic, the visible function, which restricts that region to the part which is visible from the ego. So that gives us the black region on the left there. And now we are instantiating an instance of the class oriented point. That's a built-in class in Scenic that represents a point in space with an orientation associated with it. So here we're creating an oriented point using what's called a specifier. So in Scenic, the way you create objects is with this new keyword that you see there, and then a list of specifiers. And specifiers can work together to specify the different properties of an object. So you could specify the position one way, the orientation a different way. We have a lot of different specifiers in Scenic that mirror different ways in natural language. You can specify where something is, which direction it's facing, and so forth. And specifiers allow you to mix and match those to build up a complete definition of an object. And we'll see some more examples later. This particular specifier on takes a region and it specifies the position of the object you're building to be uniformly at random within that region. So here, the spot gets picked to be a random point within this region. And in fact, it's going to be oriented. That's kind of a subtle point here. This curve region has a preferred orientation associated with it. When we define this curve region, we have it oriented kind of along the length of the curve. So what that means is that this spot that we sample will also be oriented along the curve. And that'll be useful for us in a second. Okay, next we're going to pick the angle for this car to be parked at. And we're doing that here by picking first a random angle between 10 and 20 degrees. So the range here means a uniformly random sample between 10 and 20, putting that in degrees, and then I'm multiplying that by either 1 or -1, uniformly at random. So you're going to get a 10 to 20 degree angle in either direction. Oops, yeah, so this gives you a uniform distribution over that interval. This gives you a uniform choice over the given values. And now to actually create the car, I'm going to use a couple of different specifiers for that. So first I'm going to say, create the car left of this spot by 1/2. And notice here, we don't want the center of the car to be 1/2 meter to the left. It should be the right edge of the car is 1/2 meter over. So depending on how wide the car is, we would have to position it at different places. The left of specifier that we're seeing here takes that into account automatically. So this will depend on the car's width, which we haven't actually specified yet, but Scenic will make sure it will sample the width first before then going to evaluate this position by taking the spot and moving 0.5 meter to the left. Oops. And because this spot is an oriented point and is oriented along the curb, this 0.5 meter to the left will be perpendicular to the curb. So even if the road was not facing due north, we will move 0.5 meter to the left instead of like 0.5 meter to the west, which is what we would get if we were using like global coordinates. So this oriented point in Scenic gives you a way to define like a local coordinate system, and you can specify offsets with respect to that. So that specifies the position of this car. And for the angle, I'm going to use the facing specifier. I'm saying facing this bad angle, again, not in the global coordinate system, but here I want that relative to the direction of the road at that point. For that, I'm using this road direction object, which is an instance of another primitive Scenic data type called the vector field, which provides at every point in space a direction. So the driving library defines road direction to give you at every point on the road what is kind of the nominal traffic direction to drive. Of course, in an intersection, we have to pick something arbitrary. We have more sophisticated APIs if you want to know, like at a point in the intersection, what are all the different directions you could drive. Okay, so here, the relative to part is an operator that's built into Scenic, which depends on the car's position in this case. So notice road direction defines a different direction at every point in space. So how do we know which point to use? Scenic knows that we're in the process of defining a car, so it will use the position of that car by default. It will look up the road direction at that point and then compute the bad angle relative to that. Okay, so the end result here is we get something which is 0.5 meter away from the curb and which is 10 to 20 degrees off of the road direction at that point. There are a few other things in this program that are implicit in this program. This is actually the complete Scenic program. You can run this and it will work as written. There are a few other things built into Scenic. In particular, Scenic knows that objects cannot overlap. So it will ensure, for example, that the ego car and this new car don't intersect each other. Also, when we define the car class, we add some default requirements, namely that cars have to be contained in the road unless you explicitly say otherwise. So we won't accidentally, like if you imagine there was some road that was so narrow that this car would not fit, like it's a little tiny alleyway and this car is too wide for that, Scenic will not generate a scene where it tries to force the car into that alleyway. And actually, I should have updated this. We used to have a requirement by default that the ego can actually see the other car, but now in 3D Scenic, this is off by default. So I should have removed that one. Okay, so this is a complete Scenic program, and it illustrates for you basically all the key features used in static Scenic, how you create objects, specifiers for positioning and orienting them, some of the operators and random distributions that are built into Scenic, and some of the core data types like regions and vector fields. If we then run this, Scenic will generate a sample from this scenario to give concrete values to all of the object's properties, position, orientation, etc. And so we can then take those scenes and through Scenic's interfaces to various simulators, generate data. So here are 4 different images rendered in GTA 5 from 4 different scenes sampled from that same Scenic program. And you can see that in all of these cases, you get a car which is by the curb and which is at a funny angle, but there's a huge amount of variability in terms of the distance from the camera to the car, the time of day, the type of car, the exact positioning, that sort of thing. Okay. You'll notice in that program, I actually didn't say anything about time of day, etc. So the driving library put in reasonable default values for all of those things. And also things like the color of the car. We have some realistic distribution on those. Questions at this point? Yes.
Background environment. So is there any
Yeah, so the question is about what the background environments can be. So that is, there aren't any environments built into Scenic, but some of the simulator interfaces allow you to use environments that are built into some of the simulators. So in the case of GTA 5, it's kind of a strange simulator in that there is only one, there's just like the world of that game. You can't really customize it very well. So there we had kind of the GTA library for Scenic encodes information about part of that fixed world. So we could say things like, okay, put the car down in this part of that simulated world, but we couldn't do things like add a new building, right?
Yeah.
Other simulators, you could import your own world with your own buildings, etc. So for example, in Carla, which we'll show later, Carla has several built-in worlds, and Scenic can run its scenarios in any of those. And it also has facilities for building your own custom ones, and Scenic will work with those too. The main thing that you need to get into Scenic is if you're using our driving library, in order for things like curb and road direction to be defined, Scenic needs to be able to know what the road network is. And so the Scenic driving library can import any map in the Open Drive format, which is a standard format for road networks. There are other formats, many of which you can convert into Open Drive. And so that's what we've done for Carla, MetaDrive, LGSVL, all the driving simulators we've worked with. Yeah.
And,
Yeah.
So it does on the road, right?
Uh-huh.
So you put an environment for car, it already knows where the road will car.
That's right. So basically, when you actually use this, you have to say which Open Drive file you want to use. And then this driving model that we're importing will parse that file and extract where are the roads, what is the direction of the roads, where are the intersections, all that kind of stuff. Yeah. But that's just, I should emphasize that this is just a library. It's not like something that's hard-coded into Scenic somehow. So for example, if you have your own application domain for Scenic where you use some other format for specifying the world, you can write a library in Scenic that can parse that and extract this information and make it available to Scenic programs. So for example, in robotics, there are some other formats that people use pretty typically, like USD is used in Isaac Sim and some other things. So our prototype Isaac Sim interface, for example, actually parses the USD file and extracts information from that. So, and Scenic, I will also mention, this maybe become clearer later, but Scenic looks a lot like Python, if you're familiar with Python, and in fact interoperates with Python. You can embed arbitrary Python code in Scenic files, and you can call out to arbitrary Python functions, which is exactly what these libraries do to do things like parse these files, etc. So if you have existing code to work with the formats that you use in your application, it's usually pretty easy to invoke those from Scenic as well. Any other questions at this point? Yes.
Is there a to know like where issues? So like for example, you have a new car left of spot.
Yeah.
0.5.
Yeah.
Maybe I like reverse that and I say car to the left of the spot.
Yeah. So Scenic does have a formal grammar, and in our documentation online, there's a syntax guide which has the syntax of all the operators and specifiers and so forth, with links to like the detailed specification of all of them. There is actually the formal grammar that is used to parse Scenic too, if you want to read that. Probably too low level detail. But yeah, the documentation lists the exact syntax for all of these things. In terms of order, I'll just mention these specifiers like left of and facing. There is no order for those. So when you create an object, you can give a list of any number of these specifiers, and Scenic works out automatically the order in which to evaluate them so that everything gets sampled properly. Or if like there's a cyclic dependency, it will tell you. So the syntax has been designed to look like natural language so that it's easy to understand. But it is formal, and the documentation says exactly what the allowed operators are. Other questions? Okay, so
I do have one question.
that is it then for the first presentation. So now we are going to go over to the Okay, I'll just mention, since you
I
asked about
do.
documentation, I'll put this up again later, but we have our main website, sceniclane.org. From there, you can get to the documentation page, which has installation instructions, longer versions of the tutorials we're doing today, etc. The syntax guide is what I was just referring to. It's just one page that summarizes all of the syntax, and you can click on anything that you want to know about in detail, and it'll take you to the detailed specification of that. So that's all there. We also have the forum, which is a great place to ask questions about Scenic and get help. Okay, so let's move on then to the first hands-on part. So on the workshop website, in the session right now, there's a link to the Colab notebook. I also have this QR code if that's easier for you. Please try playing around with that now, and we will be here to help out if you have questions or get stuck. What I will leave up while you're working on that is this cheat sheet I've put together, which has essentially almost all of Scenic's syntax for static scenarios. So in the top left, you've got the built-in classes, point, oriented point, and object with their main properties. In the bottom left, we have almost all of the specifiers that are built into Scenic. And you can see there are a bunch of different ways of positioning objects, like at a specific location or above or left of relative to some other object, randomly within a region on some surface for 3D things, facing different directions or facing towards an object, etc. We have all of those. Again, these can be mixed and matched. In the top right, we have the probability distributions that are built into Scenic. One thing I forgot to mention earlier is you can use this require statement to impose declarative requirements on your program. So just like Scenic requires by default that objects cannot intersect each other, you can also add extra requirements using the require statement. So you could say, for instance, require that the distance from X to Y is at least 10, and Scenic will figure out how to ensure that. And then we have various operators that you can use, like the distance, etc. These are helpful in requirements. And then if you want to define your own classes, I've thrown that in the bottom here as well. There's a question, Fida, go ahead. Oops, wait a minute. I forgot. I got to turn the sound back.
Can you hear me?
Yeah, now I can.
Yeah. So my question is, I know the Scenic, like the static part, but my work is more related to dynamic part. So do you suggest me to join the breakout group and breakout room?
Right. So the question, in case people couldn't hear it, was, oh, shoot. Hold on a second. Okay, so the question was, if you already know about static, excuse me, if you already, sorry. If you already know about static Scenic and you want to learn about dynamic Scenic, that's going to be the subject of the tutorial after the coffee break. So if you want, you can go into the office hours now and ask other questions there and then come back for that part. Or if you want to just go ahead and start working on the dynamic Colab notebook now, you can, although we realized we made some last minute change to it and have to update the link on the website. So I think you might want to wait a few minutes for that so I can update that. Okay. All right. Any other questions? Okay, then I encourage everybody to get to the Colab notebooks. The link is on the conference website and start playing around with those.